Welcome, ladies and gentlemen, to this video tutorial. Let's take a look at this question, which is exercise 4.4, number 3, A and B. Let's take a look at this function, little f, which is defined piecewise as x plus 2 when x is between minus 1 and 0, and x minus 2 when x is between 0 and 1. So first of all, we want to show that little f does not take on its average value. So little f is defined as little f maps from minus 1 to 1 into R, and is defined as what? It is defined as x plus 2 when x is between minus 1 and 0, and x minus 2 when x is between 0 and 1. So let me just double check that I got that right. It looks like it. Okay, so before we start, let's just think about what the graph of little f looks like. So when x is positive, it looks something like this. So we're interested in what f does from minus 1 to 1. So here f looks like that. It's not it doesn't take on the value 2 here at 0. It takes on the value plus 2 over there. So the graph of the function looks something like that. And we can see here, well, what are we going to get? My drawing is a little bit off, but everything is symmetric, so it looks like the average value of f should be equal to 0. And that is, of course, what we get. So if we work out the average value of f, that is 1 over the length of the interval multiplied by the integral of f from minus 1 to 1 of f x dx. But this is the same as the integral from minus 1 to 0, and on that interval x takes on the value x plus 2 dx plus the integral from 0 to 1 of x minus 2 dx. And this integral is fairly straightforward. So what is that? That is a half x squared plus 2x evaluated between minus 1 and 0, plus the integral which becomes a half x squared minus 2x evaluated between 0 and 1. And that becomes, and this is just brainless arithmetic, this becomes a half minus 2 plus a half minus no, let's just be careful. That becomes a half minus 2. Oh, somewhere I seem to have made a mistake. Be very careful with your arithmetic letting me down. So let us do this properly. That's a half 0 plus 2 0 minus a half squared minus 2. Put your brackets in there. Plus that is a half minus 2 minus everything is 0 there. So that is all 0. So that is a half. That is minus a half plus 2 plus a half minus 2. And as we expect, The halves cancel, the 2's cancel. 0 times a half is equal to 0. So the average value of f is equal to 0. And that is exactly what we expected from the graph. However, notice here that for no value of x in the closed interval from -1 to 1 is f of x equal to 0. So what is going on here, if we think about this in terms of the integral mean value theorem, which is theorem 4.4.4, we'll explain why A does not contradict theorem 4.4.4. So theorem 4.4.4 says if the function that we are integrating is continuous everywhere on the interval that we are integrating, then there exists a point in the interval where f is equal to its average value. So what is the problem here? Notice here there is again a discontinuity. There is this jump discontinuity here at 0. So since f, if we think about the graph of f, there is this jump discontinuity here at 0. So since f is discontinuous at 0, or let's rather say since f is not continuous at 0, the integral mean value theorem is not applicable. So theorem 4.4.4 is not applicable. To f, because theorem 4.4.4 requires that the function little f be continuous everywhere on the interval that we're integrating over. And this is not the case here, as we have this discontinuity at 0. Okay, and that is it for this one. I will see you in the next one.